Good morning, everyone, and welcome. Today we are covering the introduction to C++, and these are some of the topics that we will cover. The parts of C++ program, the cout object, the include directive, standard and prestandard C++, variables, literals, the assignment statement, identifiers, integer data type, floating point data types, the character data type, the C++ string class, the bool data type, determine the size of the data type, and more variables, scope, arithmetic operators, and comments. Again, some of this information that you see here in this presentation is what you will see in Solo Learn, like the first module. It's very important that you understand the basics before you dive into loops, functions, and so forth. So at least you can start a basic program before you get into the logic, right? So these are the essential part of C++ program. You have the comment. When you see the two slashes, there are two parts of comments we will discuss and show you. And then you have the include IO stream. This is a preprocessor directive. Basically, this is the header that you're saying what you will use. And then you have a using namespace std, which is a namespace to use, meaning C++ or C uses a namespace, meaning it's a way to organize so that variables or identifiers that you're using do not collide. Basically, you're saying I'm using this namespace std, so that if there was other namespaces similar to it, nothing is colliding. It's just a way to organize the program. And then in most of the high-level languages, you have what's called a driver, where everything runs, right? Or what's called the main. So here you have int main. So this is the beginning of a function named main. The main is basically the driver. Even if you have other functions, this is a function. And last class we discussed how you know it's a function? Because it has parentheses. And when is the first time you have seen functions? In math class. You see f of x. And the x is inside a parenthesis to show you it is a function. And the x that's inside in the math, that's a parameter that you're passing on, which we will discuss later. And some of these high-level language, it uses braces to show it's a block of code. Okay? And each brace that you open like this, you have to make sure that you close it. And then here we have a cout. It's a way to put out, right? Cout, hello world there. And then you have to end it with a semicolon to show that's the statement. It's the end of the statement. And return 0 is basically you're sending this to the operating system. We are not returning anything, is what you're saying here. You're returning 0 is what you're saying because we started as an integer. And then this is the end of the block code. And I'll show you an example of this. So here's an explanation of what I just said, the comment, the include path, the preprocessor, the namespace to use, and so forth. Okay. These are some special characters. The double slash begins with a comment. The pound sign begins with a preprocessor directive. The less than the greater than, it's open close brackets, encloses file name used to include directive. And open close parentheses used when naming a function. The braces enclose a group of statements, and the quotations enclose a string of characters, semicolon to end programming statement. Okay. Some important details. C++ is a case-sensitive. Uppercase and lowercase characters are different characters, so main is not the same as small main. Okay. Every brace must have a corresponding closed brace, and vice versa. The cout object displays information on computer screen. They use less than to send information to cout, and then you can use the two less than signs to send multiple items to cout. You can write it like this: cout hello comma with a quotation, and then this is basically saying another cout. Okay, you can combine that, or you can break it down into two parts like that. To start a new line, you can get multiple lines of output screen using the NL or N line, or you can use the /n to show it's a new line. Okay, so these are some escape sequence. This is the same almost in any language, okay, whether it's Java, PHP, and so forth. Okay, even HTML. The include directive inserts the contents of another file into the program. It's a preprocessor directive, so it's not part of the C++ language and not seen by the compiler. Compiler doesn't see it. Okay. So the pre-standard older style C++, you used to use .h, like include iostim.h or include math.h. Okay. So at that time they didn't use namespace. Okay, and it might not return 0. Then we have what's called variables. It has name types of a data type. It can hold. The character will be the data type, and the letter would be the variable name. It's used to reference a location in memory where a value can be stored. Okay, so you have we kind of touched this last class. You have the data type, and you have what? The variable. So, what is a variable first? What do we say a variable is? It can change to what it can hold. Variable, right? When they say the word is variable, it means it changes, right? So it can change what it holds. But it's a temporary location where you can save something. But now this variable has a type or a data type. Data type means information type, or type of information you're saving in this variable. We call this what? Data type. So each variable, before you give the name, you have to talk about the kind of information that it can hold. Does that make sense? So if you say character letter, you're saying I'm trying to hold a character type, and I'm going to call this variable a letter to say that I'm putting a letter in there. Does that make sense? If we say integer, right, then we are saying we are trying to hold some whole number, whether it's positive or negative, right? So we will say what? Integer. So we're saying an integer is a variable, a data type, and then I'm trying to hold it. Now, if you say integer, then whatever variable name you're about to give has to be something that you know will be like a whole number, like age, right? If it was a tax rate, would it be an integer?
Double.
It would be a double or a float, right?
Yeah.
Okay, so double would be we're expecting some type of decimal. Does that make sense? If we say a string, a bunch of words, right? Alphanumeric, we're trying to hold something. So basically, if it's inside a quotation. And then you give a name, whatever it is. So for example, if I say string name, then I'm saying it's a string, so a bunch of words. And then if I say name, now I know this variable will hold a name. Does that make sense? Can I say string age? You can say, but it doesn't make sense. It's better to say integer age. Does that make sense? So here's some example. So you can say int age, and then age equals 17. Int age, you already said, okay, you're declaring it. I need a data type that's integer, and I'm going to call it age. Now I'm setting age to be 17. Does that make sense? You can do this at the same time, integer age equals 17. You can do that. And then now you declared it. You assigned a value. The equal sign means assignment. Now you're saying print age for me. Okay? Now age is printed to be 17. Now you're resetting age again to be what? Remember we are calling this what? Which means what? Okay, now we are saying age to be 18. Now if you say see out age for me, what prints? 18. Does that make sense?
The question. When you were talking about the decimal numbers, you said it could be a double or a float. What's the difference?
So it's the number of decimal places you can have.
Okay.
So if we say a float, you can have up to 7, is it 7 or 8 decimal places, which we will see soon. And then that will be double of that. And then we have a short, which is double of that. Then we have long, which is double of whatever the short is, and so forth. Okay. So it depends on how much space you need to hold that memory. Remember, when you hold this, when you are declaring this and you're holding on a variable, you're asking, I need this much memory in the, this much space in the memory is what you're saying.
So we're talking about how many numbers are after the decimal point?
Right.
Okay.
Okay. So use the equal operator to assign. So when we say item equals 12, or when we say age equals 17, we are saying what? That is an assignment. All right. So it copies the values on the right to the left. So So we discussed what's called constants or literal. So literal will be data item whose value does not change during the program execution. It's also called a constant. So a single quotation or double quotation, that would be a character constant. The hello would be a string literal. 12 is an integer constant, and 3.4 would be the floating point constant. Make sense? Then we have what's called identifiers. These are programmer chosen names to prevent parts of the program, such as variable, to represent the parts of the program, such as the variable. For example, when we say string name, you call that a name. You could have called a string F name, first name, put in L name, last name, to specify. Okay. So you cannot use C++ keywords as identifiers, like the main or include and so forth. It must begin with alphabetic character or underscore followed by alphabetic numeric or underscore. Okay, and we will see some examples in the next screen. Or you can have multi-word variable names, or you can say F first name, first underscore name, and so forth. Okay. So here, what is valid and what's not valid. So you can have total sales, you can have a camel case, or total underscore sales. You cannot have the dot. So total dot sales, you cannot have that. Or fourth quarter sales, you cannot have starting with a number. Or total sales, if you're using that dollar sign, you cannot have that. Okay. Then we have what's called integer data type, which we just explained. It can be signed or unassigned. Okay. When you say it's signed, it uses 1 bit in the memory, but if you say unassigned, then you can use all the spaces that it holds in the memory. Okay. And that's what this discusses. Defining variables. Variables of the same type can be defined in a separate statement or in the same statement. You can say int length and then int width, or you can say int length, comma, and then width. And you could have it all in the same line as well. Okay. However, variables of different type must be defined in separate statement, meaning that I cannot say int age, comma, and then like name. Does that make sense? Because name needs to be a string, right? Unless you're planning to hold name to have a number. Again, whatever variable, when you're declaring these variables, make sure the name reflects what's trying to hold, so that if somebody else comes after you, they can read the code and it makes sense. Okay. An integral constants. To store an integer constant in a long memory location, put L at the end of the number. Constants begin with 0 octal or base 8. And the ones that begin with 0x are hexadecimal or base 16. The example we went over last class was base 2 with binary numbers. Okay. So we have floating point data types, so designed to hold real numbers, 12.45, negative 3.8, stored in a form similar to scientific notation. Numbers are all signed. Available in different sizes, number of bytes, float, double, long, double. Size of float is less than the size of double. That's the question you're asking, right? Yeah. And then the size of a long is also less than that. Floating point constants can be represented in fixed point decimal notation, or you can represent it like that. Double by default can be forced to be float if you want it. And that's why people go with the double. It's easier, so that in case you needed more decimal places, you can still hold it there. But remember, it's taking more space in the memory, in the RAM. If a floating point value is assigned to an integer variable, so the fractional part will be truncated, okay, chopped off and discarded. So that's what they try to avoid. So sometimes we say, you know what, let's just use a double. Then you have the character data type used to hold a single character or a very small integer value. Usually occupies 1 byte of memory. A numeric code representing the character is stored in memory. Okay. Then the character literal is a single character. When referenced in a program, it's enclosed in a single quotation mark. As you see there, so the quotation marks are not part of the literal and are not displayed. So string literals can be stored as series of characters in consecutive memory locations and stored with a null terminator. Okay, and that is between the quotation. So should you use a character or a string literal? So a character literal is a single character enclosed in a single quote, and a string literal is a sequence of characters enclosed in a double quotes. So a single character in a double quote is a single literal, not a character literal. Okay. must include a string to create and use string objects, and you can define string variables in programs as string name, and you can assign values to string variables with the assignment operator, like name equals George, or you can do it in the same line. You can display them with a cout. My name is, okay. And then we have a Boolean data type, which holds what? True or false, or 0 or 1. And determining the size of a data type. There are some built-in functions that come with most high-level languages. So this is an example of the size of operator gives the size in number of bytes of any data type variable. So assigning values to a variable. So previously created variable, a single variable name must appear on the left side of the equal sign. So here you have int size, and then you have size equal to 5. You cannot assign the variable to a number, but a number to the left. Does that make sense? Variable assignment and initialization. So the first example that we have seen, we had int age, and then the next variable was what? Age equals 17. Okay? Or you can do it all at the same time. So int length equals 12, or int width equals 7. Okay. The scope of a variable is that part of the program where the variable may be used. You know, when somebody speaks and they say, "Oh, it's not part of my scope," what do they mean by that?
They don't have knowledge.
Say it again.
They don't have knowledge of that area.
They don't have any access to it. The same thing in programming. It doesn't matter what programming you do. When we talk about scope, we are talking about the accessibility. Do you have access to it? Does that make sense? So when you define a variable or declare a variable, you can only access that variable on where it's defined. Let's consider, we'll discuss functions later, but let's consider this class to be a function. Like even in math, function. Okay? So if this is a function, and the other class is a function next to us, if they have their own variable that holds, let's say, Ali, do we have access to that Ali? Do we see it? So that's what, it's not in our scope. But if we have Ali here, even though it's the same name, we have access to this. So this is basically the scope. We can access this Ali in this class and use it, but we cannot access that one and use it. Does that make sense? So this is what's called the scope, the accessibility. However, if that variable Ali was outside next to that tree, if they look at the window, they are able to see it. If we look at the window, we are able to see it. Does that make sense? So we can access it and call Ali, and Ali will see us or hear us, and then we will be able to use it. If they call, and they can also call and access it. This is when you define a variable, and if it's global, outside of these functions. So if it's global, we are able to use it. Again, this is what scope is. Do you have access to it? Okay. And then we have what's called arithmetic operators, which is similar to what you see in math. Okay. The plus sign, the multiplication, the division, and so forth. Okay. You have C++ has unary, binary, and ternary operators. So you have unary, 1 operand minus 5, binary, 2 operators, and 2 operands, and so forth. The arithmetic operation, almost everything should be what you already know except the last one, modules, or the percent. Percent, the modules, this is basically what's called the remainder. So if you have 5% 2 or 5 module 2, do you say the answer is 2? No, it's the remainder. So it's like you're saying 5 divided by 2, what's the remainder? You say 1, right? The same thing, modules is the remainder, whatever the remaining number is. Okay? And then the operators and how they are used. Okay? All right. We just discussed this. Then we have comments. Comments is just a way to explain a line of code or a complex part of the code, what it means. So somebody else, or even for you, that you wrote a program and you want to go back and have an understanding of your program, you explain what that function is. You explain what that line of code is. You explain what that variable is. So if the program is big, it makes sense later on. Oh, this is what I was trying to do. If somebody else comes in, this is what this person was trying to write or they meant in this program. So it's very important that you comment your program or document as much as possible. Okay? The compiler doesn't see it. It's just for documentation purposes. Okay, so you have a single line comment. So here you have int length equal 12. You're saying length in inches. Int width equals 15. Width in inches. You're explaining it. Int area, your calculated area. And then you can have it on top of the line also instead of the same line. Calculate rectangle area. Okay. And then you can have multi-line comments. So you use the / asterisk and then end it with asterisk /. This is a block of code. So an example of that. And it's good, especially you will use this in the header of your program. You write your name, what the program is about, the date that was created, what it's trying to achieve. Very important in all your programs which you are required to do as you submit your projects. Okay. So any questions so far? And I'll show you what we did in to demonstrate. They usually include, we were talking about the using namespace std. Let's start with the comments so you have an idea of how it works. So here we can put, if let's say we start with a block code. Okay? As soon as I put / asterisk, you will see that everything is commented out. Okay, so I can put a line in here and say program. This program is for testing purposes. Okay, and then here say name or author, date. What's today's date? January. I can't believe time is flying. We're in 2020. Any other information you want to add, and then after that we do the asterisk and then the /, and there you go. All of a sudden, after I close that, our code appears again. You see that? You can put this brace here, or you can put it here so that it's organized. Give yourself some space, and then whatever you're trying to do. Make sense? So let's define some variables. Declare. So we have here, you can say string and then name. You can also declare int, maybe age, or yeah, number. I can write num, but try to write more so that it makes sense. Okay, int number, and then you can see out something. Or ask a question. See out is what? To show something to the user, right? In this program, we will ask you about your name and guess a number or something like that. And then we put a /n. What's the /n we discussed earlier? For a new line, and then semicolon to end that statement. Okay. And then after that, now we can ask a question. So cout to output something, and then cin to ask the person a question. So we put /. We're saying you now. Because the arrow are pointing to the right, so you're saying you. The output was us. Okay, we'll give it to you. So think of that, the 2 point going out. Now you're asking the user the input, cout. Now we can just say, actually before we do cout, ask the person their name first, right? If we said that we are going to ask you the name. So let's say, what is your name? right? And then we end that. Now here we can say, let me move this up. Okay, so here we can say cn you can just say name like that, and then here we can ask both questions at the same time, or so that we have some type of interaction, we can say cout hi, and then here by their name, right? Hi, whatever their name that they type, right? Yeah. Okay. And then cout. So you're saying hi, and then we can say welcome. Close that. Now you can ask the other question and say what? Cn. Or we ask the question. Yeah, keep asking the question and then say guess a number. And then now we can put out whatever number they guessed, right? So we say, sorry, we have to capture that number first, right? Guess a number, and then we will say sin number. That's what we're calling it, right? And then now we can put out. So here we say name, and so you have guessed. Then here you can say number. Does that make sense?
So Cn is what you, can you explain Cn again?
Cn is the input. We covered that yesterday. So you don't miss it, okay? All right, and then the cout is to output. In basically out for output, in for the input. Does that make sense? Cout to the user, like the print out. Cin to capture it. Okay. Now let's. So here we discussed about comments if it was a block. So let's do some statement comments. So here we can say a variable to hold name or something like that. Here, a variable to hold the guest name or something like that. You know, each one of them you explain what you're trying to do. Okay? And then after that, we click on run. Now, the reason I was saying that if you do the code breakdown in Solo Learn, it expects all the answers one time. While when we run the same program here, I will show you there is actually the interaction that we expect. But anyways, let's run it and see. Now, when we run it, here it says, you know, it seems like your program requires to run input. So now there are two questions that are asked here, right? So the first one is the name. I can type Mohammed, right? And the second one is guess a number. Huh? 1. Because I want to be the one in that race. All right. So now let's submit this. And once the program runs, it says what? In this program, you will be asked about your name and guess a number. What is your name? Right? Hi, Mohammed. Welcome. Guess a number. Mohammed, you have guessed 1. Now, everything is in one line, right? You see that? Everything is in what? In one line. Now, if we need a break, we need to put what? That /n to make sure that we have a break. Right? So here, what is your name? So after this question, we might want to put what? A /n here. And then and then you have Mohammed welcome. And then after that, after the welcome, we actually need what? Another slash n there. Okay? And what else? Guess a number, and then after guess a number, we also need what? Another slash n there. Now the same program, if we run it again, and then we give it a 1, and we run this, you see that? It's better looking a little bit. What's your name? Hi, Mohammed, welcome. Guess a number. Mohammed, you have guessed 1. You see that? Now, this is in solo learn. Let's take this code and try to run it in Replit and see what happens, right? So if I paste it here, let me make it bigger so you can see it, and try to run the program. So we have the run button right here. It says, in this program, we will ask you about your name and guess a number. What is your name? So I'll type my name. Hi, Mohammed, welcome. Guess a number. See that there is some interaction going on. Okay? Okay, I'm guessing the number 1. Mohammed, you have guessed 1. See that? So there is interaction going on here, as opposed to on the other side, you expected to put all your answers one time. So you can use either or, and whichever one you feel comfortable with, that's fine. But again, just think about using this online IDE on this one, because it allows you to interact as you write your program. So any question on this so far?
When I ran it without using namespace, I had a standard for each line.
Yeah, what?
When I ran it without using the
Namespace, you have to add standard, yeah, STD.
and not get to use standard each line.
For each line. It's a hustle. So I use it. So he's saying if we don't use using namespace, we should have to use STD, this STD right, is standard, in each one of these. So I do that. Okay? So any question? So this is what you are supposed to cover. Just basically do some reading ahead of time in here. So you're supposed to go through that. So at least that when we go over it today, it won't seem overwhelming. Any question? Is it easy? Good. All right, so I want you to practice what we did and work ahead so you don't fall behind. And I think we have somebody presenting today.